In a book that I wrote with Kevin Mitnick, The Art of Invisibility, he and I went round and round about password managers. Kevin, he supported them because they allow for greater complexity. I, on the other hand, do not support them because if an attacker went after that one password manager and was successful, then potentially all of your passwords would be exposed. Early in my career at CNET, I found a bug in Norton Internet Security. By typing random characters on a keyboard, I could suddenly pop open the Norton Password Manager and see all the passwords that I had stored in plain text. So, I haven't been a fan of password managers since. What happens if you are a developer and you need to access a variety of systems and your employer requires the use of a password manager? Well, that could get interesting. In December 2022, and again in February of 2023, LastPass Password Manager disclosed that it had been breached, and potentially passwords for thousands of systems were exposed. The details, though, are interesting. In this case, LastPass said that one of its DevOps engineers had their personal home computer hacked and infected with a keylogger. In the December 2022 breach, LastPass revealed that the threat actor had leveraged stolen information to access cloud-based storage environments. In the second breach, disclosed in February 2023, LastPass revealed that an attacker was able to leverage valid credentials stolen from a senior DevOps engineer. This is the new normal. Rather than develop a chain of 0 days, even known exploits to break into a system, why not just walk in through the front door with some senior developer's credentials? It's much easier, and it's less noisy. Of course, the senior developer had access to a company's source code. The point is, we tend to rely on tools out of convenience. Rather than developing a password schema and only write down the first part of that, which is something I recommend, we have password managers. And rather than parsing code from source, there are code editors. In a moment, I'll introduce you to two researchers who presented at DEF CON 31 on how the code editor used by 80% of the developer community today had a flaw. It's now fixed. Still, it's a reminder that even the code tools that we use and rely upon daily, well, they can sometimes be faulty. Welcome to The Hacker Mind, an original podcast from the makers of Mayhem Security. It's about challenging our expectations about the people who hack for a living. I'm Robert Famosi, and in this episode, I'm discussing how there's no standard threat model for code editors today, and how, even though this is a tool we probably use every day, sometimes even without thinking, we need to be checking them for vulnerabilities. One of the more interesting talks at DEF CON 31 this year was entitled Visual Studio Code, is why I have Workspace trust issues. From their abstract, the researchers state that modern development tools offer increasingly advanced features and deep integration into ecosystems, sometimes at the cost of basic security measures. Code editors, then, have tried to counterbalance this by introducing new lines of defense, i.e., Workspace trust, leading to a cat-and-mouse game to restrict access while keeping those features available by default. I think you can see where this is going. So I wanted to talk to the presenters to learn more about this trust issue.
All right. Is it rolling already? Or?
We're rolling.
Alrighty. Okay. Hi, I'm Paul Geste. I'm a vulnerability researcher in Sonar's research and development team. And yeah, I love to break web things, especially in the JavaScript world. I used to be a developer, but then I got hooked on CTF competitions. And yeah, now I'm a vuln researcher in the R&D team. And instead of solving challenges and writing write-ups, I audit open source projects and write blog posts about it.
Hello, my name is Thomas Chauchefoin. I'm French, as you may guess, from the south of France, but every day is sunny. I've been in this security industry for 6 years now, and I've been a volunteer researcher with Sonar for 2 years. And actually, I joined the same day as Paul, and we share the same passions and roughly do the same work.
Sonar is a company that looks for security vulnerabilities and hotspots in code review using static analysis.
Sonar helps developers to write clean code. And under clean code, that means that it's code that's of quality, so you have less functional bugs, and also that's safe, so you have less security bugs or vulnerabilities. And we're trusted by more than 7 million developers, and we're pretty proud of what we're doing.
So before we get started, I want to establish that before both of these men became professional security researchers, they started with capture the flag competitions. In early episodes of The Hacker Mind, I talked with members of the Plaid Parliament of Pwning, the team that has won the most DEF CON CTFs. And some of their members today are working for the NSA and Google. So I asked Paul and Thomas about the CTF scene in Europe and how it might be different or not.
Yes, so I'm from Germany, and here in Germany we actually do have quite a good and strong CTF scene, I would say. So I got into it just by starting my studies on IT security here in Bochum, Germany, and here we have a student team. It's called Flagsfingers, and we basically do a thing called Flags Rookies, where we introduce new people to the CTF scene. And because it can be quite hard. The top players that are experienced, they want hard challenges. And if you start out, you will probably run against the wall and it won't be fun. So we try to have beginner friendly challenges and we help people out. So that's how I got started. And I think a lot of the teams in Germany and throughout Europe are based on, student teams, university teams, because there you have, the local, thing where you can join together, meet up, play together there, which is always more fun than over Discord or online.
So Paul's from Germany. Thomas is from France.
I think it's roughly the same thing in France, right? It's mostly we all start as students and we don't know it's a profession yet. So we just have fun. We play, we discover new stuff. I think we build knowledge with CTFs all the time. In my case, my only exposure to security before working in this industry was through CTFs. So everything I knew at the time was thanks to CTFs. So I think it's really powerful.
So are there any major CTF competitions in Europe?
There's this website called CTF Time, where there's a list of all the big CTFs, and you have you can rate them, and they have a rating then, a score where you can see which ones are rated higher and which ones are rated probably lower. So you can go on there to see, for example, the CTF that me and my team are hosting, the Haklu CTF, is pretty old. We do it since 2011, and it's also one of the highest rated ones. But then, of course, in other regions of the world, for example, DEF CON CTF, there you have the very prestigious names, and also recent additions from the Asian room. Real World CTF is also a pretty cool one that happens every year. That's, based on the name, is very close to the real world. They have 1-day challenges or sometimes even 0-day challenges where they just give you a piece of software in the latest version and in a maybe slightly weird configuration, but then they say, let's go. You need to find a way to get remote code execution. So it's becoming very close to the real world.
So you're successful with CTFs. How does one take that experience and turn it into a professional pen testing career?
Yeah, I guess, as Thomas already said, you start out just to have fun, just to play, just to see what is this thing, what's going on. And then you learn a lot of your practical skills. For me, I was playing it while studying. So in university, I got the lectures and the formal education and everything in theory. And then I could use some of that in practice and learn even more practical skills with CTFs. I think there's a big difference between hearing about something in a lecture or doing a small exercise for it and actually going through the full path of finding a vulnerability, exploiting it, and maybe even reporting it, making a write-up about it. So yeah, you learn a lot there, and then at some point, the world becomes the challenge, if you want to say so, where you can just take any, let's say, open source project and start auditing. But of course, in the CTF, you know there is something, and in the real world, you don't know it. There probably is always something, as we all probably know, but yeah, you don't really know it. So during my CTF career, if you want to call it a career, I also built up a high frustration tolerance, where if you play 48 hours CTF, of course with sleeping breaks, but if you don't find anything, playing one challenge for 2 days straight, it can be pretty frustrating, but still you learn a lot along the way, of new technologies or of things that don't work, and the next time you know that they don't work. And in the end, you can read somebody else's write-up, and then you will learn what the vulnerability was and how to exploit it.
Lately, there's been the emergence of bug bounties. In episode 9 of the Hacker Mind, I talked with someone who traveled the world with HackerOne, getting paid to find bugs in various code bases. So has either Paul or Thomas ever done any bug bounties?
Yeah, I did some bug bounty in the past, and I don't do it anymore. There are like different kind of bug bounties in practice. You have the famous one with HackerOne, Bugcrowd, platforms, kind of web bug bounties. There are also some other way to sell bugs in the way they will be disclosed, with like competitions like Pwn2Own. So I stopped doing this web bug bounties because it's most of the time only black box auditing. They give you a website, you have to break into it, but you don't get access to source code or anything, and I find it much less fun. I really love to have code and just dig into it, try things, and just like it. I find it more creative and less, always the same thing. But we still played Pwn2Own together with the Sonar R&D team. It was pretty cool. Different kind of targets than the one we are used to. So we can call it bug bounty in a way.
Speaking of bug bounty, sometimes we also do get bug bounties for the things we report from our Sonar work stuff. So every time we find something, we report it, and some of the projects do have a bug bounty. I think one cool one was that the bug bounty that we got from Microsoft for one of our things we found in Visual Studio Code, which we gave to charity. And yeah, it's also quite a fun story because 1 year after we found something with the same impact, and they said, oh, wait a minute, last time we basically awarded this by error. So sorry, you're not getting it this time. But yeah, sometimes we even get bug bounties like this. And I also have to say, I prefer the way how we do it right now. We get paid to just do the research, and we don't have to. Basically, we're not dependent on the bug bounties like you would be if you're a full-time bug bounty hunter. So this allows you to go much more into depth into certain topics and not just to hunt all the low-hanging fruits to get something.
And you're also not being driven by the same incentives, right? You're not looking for money, you're looking for bugs, you're looking to improve the security of this product and this project. You're not just trying to make money. So it's also less frustrating when things go wrong with disclosure, but you're not getting paid or anything. So this is the best way to do bug bounty in a way, not getting the money.
The presentation that Paul and Thomas gave at DEF CON was about 2 vulnerabilities in Visual Studio Code extension. These are CVE 2021 43891 and CVE 2022 30129. This was the case where they found and reported one vulnerability, and then a year later found another vulnerability similar to the first.
It's called an extension. With practice, it's a built-in module that you can't disable. So it's called extension by Microsoft, but in practice, it's just a feature of the code editor.
So why were they even looking into this? What led them to even start investigating?
I would say it's the most popular IDE right now, at least in certain, let's say, language communities. A lot of people are using it. It's a big impact if you find something in there, right? Because you directly affect almost 80% of all developers essentially. So it's a pretty interesting target. Yeah, just because of that. And then it's also a big code base. I think 800,000 lines of code. There's a lot of opportunity for stuff to go wrong. So that's why we wanted to look into it. And we also, we're seeing other people, other researchers find bugs in there, and some of them were looking interesting because there's, a lot of different attack surfaces. And in general, this is a tool for developers. So it's not like a server that's running somewhere that you can directly attack over the internet. It's something people run on their own. And so it's also an interesting context. It's an interesting threat model, let's say, because for a lot of different developer tools, it's not very clear what's the responsibility of the tool and what's the responsibility of the developer. Am I or should I open this unknown file with my IDE? Can something go wrong? Is it my responsibility to not do it and to vet the file first, or is my IDE safe enough to block anything malicious? So that was also interesting to us.
This brings up a good point. If you want to attack a vendor, you might want to go through the developer writing code for that vendor's product.
Yeah, and we've seen a lot of in the wild campaigns against developers. I think the most recent example, and maybe the most newsworthy one, was on LastPass. There was this one-day vulnerability exploited. So allegedly, we don't have all the details. So one-day vulnerability exploited against a DevOps engineer who was working from home, and they kind of broke into their home network from the outside with this vulnerability, and they got access, I think, through some keylogging to their work laptop, and then they got access to LastPass production servers from this access. So in the end, if you compromise developers, you will likely get access to production systems. You will likely get access to source code, which is a big asset for companies these days. You will maybe get access to secrets and API keys, everything. It's very impactful in the end to target developers.
By now, we should all know what a 0-day is. But Paul mentioned 1 day, so I want to make sure we get a definition of that.
So I think in general, we call a 0-day everything that's not known outside of a small private circle. I think the name comes from this notion that if it's a 0-day, you had 0 day to protect yourself against this vulnerability. So it's just came out publicly. There is no available workaround or patch. And in general, we also use this terminology to say a 0-day is something that maybe your friends know, your colleagues know, but the public is not aware of this vulnerability. So nobody can protect themselves against it. And 1 day is also, we can call it an N day, to say it was 1 day, 2 days, 3 days, any number of days you want. And it's a way to say that it's something that's known, that's kind of track. It's likely got a CV ID before. Maybe there are patches available, maybe there are workarounds. But maybe in this case, the patch was not deployed. It was not applied on a given system. So you can still break into the system with a 1 day, so with a known vulnerability.
So you've targeted the system, which is used by nearly 80% of the developers worldwide. I imagine, given that it's used by so many people, that it's fairly hardened. But then you must find some area of the codes that are less locked down, and you begin pursuing it until you find some bugs that are, very interesting. I assume you go through a lot of bugs that aren't interesting.
Yeah, and like Paul said, it's 800,000 line of code. It's huge. It's like you could build small operating systems with much less line of code. It's a huge project, so there will be bugs, and like you say, there will be useless bugs in the end. But for us, what was interesting is that for such tools, you want to get a deep integration with the ecosystem of every language. And VS Code supports many, many languages. I think it's one of the reference code editors for JavaScript, TypeScript. I know a lot of people doing PHP in it, and you need to integrate with all these ecosystems to offer features to help you download all dependencies, scan the code, and help you to develop faster and better. So because of these deep integrations, it's also easier maybe for attackers to find security flaws, because you will be calling a lot of external binaries. You will be trying to do your best to offer a lot of information to the user, but maybe to collect information, you need to run code from the user that comes from the local project. You may need to call remote servers and exchange information with them. So a lot of things will be happening, and a lot of these things aren't really under control of the Visual Studio Code developers. If you, in our case, we found a vulnerability into a Git extension, and what's critical is that if you develop VS Code, you're a VS Code developer, you write the Git extension, you will call Git, and Git will do all the hard stuff related to Git for you. You don't need to re-implement Git in VS Code. But it also means that every single vulnerability that affects Git will affect VS Code. And you cannot do anything as a developer to prevent this from happening, except not calling Git anymore. But you need it to offer this deep integration with projects and the usual developer workflows. So it's a weird trade-off of, I need to do complex and maybe security sensitive things to be nice for the user, and I have no control on all these binaries and all these other components are working internally. So it's really hard to remember to make everything safe and to know what to look at.
So we've talked a lot about Microsoft, but remember, this was also a Git problem as well. I asked Thomas and Paul to explain this more. Was this an integration flaw with Git, or was there some actual code flaw?
We found two bugs in the Git extension. The first one was directly related to Git. So when you develop with Git, you can configure the tool. You can have a system-wide configuration for all your system, all your users. You can have user-specific configuration in your own folder to, set your own name when you commit, set your email address, or just some general features of Git. And then you have the project level configuration that's in the .git folder that comes with your project. And there could be, and there are sensitive options that you can set in these configuration files. For instance, in our case, we've demonstrated that if you ship and if you send somebody a Git project with a malicious configuration that could execute malicious commands, when they will open it in VS Code, VS Code would directly run Git and say, oh, can you please look into this folder and try to run some actions, like give me a status update of all files that were modified since the last time I've looked at them, or these kind of integrations. And because it uses this malicious configuration, we would be able to force the user to execute arbitrary commands on the system, which is never something that you want. And they fixed it by first asking you if you trust a folder or not. So they call it Workspace trust. If you don't trust a folder, this extension won't run anymore. So it's kind of safe. But if you click I trust, this vulnerability is still present. So they use this new trust-based system to kind of try to let you evaluate the situation. Do I know where this code is coming from, or is it just a random zip file coming from the internet? And depending on this choice, they will take riskier or less risky actions. And so the other one was related to protocol handlers. So, when you go on your web browsers, you type https:// it's an HTTPS link. The browser knows that it's going to have to connect to the internet and, do a DNS query, then an HTTP query over SSL, and display you the results. But if you type something like a file : / the browser will say, oh, okay, the user wants to access a file on my system. So I will display these files. And every app on the desktop can register these protocol handlers. So in the case of VS Code, they registered VS Code : / and it's really practical. It's really useful for developers. Like if you go on a GitLab instance, you get this clone in my IDE button. So you click it. It's the system will see this VS Code link. It will notify VS Code that, okay, somebody's trying to clone Git repository. with VS Code. So VS Code will show up and say, do you want to clone this folder? Yes, no. Why do you want to clone it? I want to put it on my desktop, for instance. And then you call Git to clone this repository. And we found that in the way this operation was done, so like it needs the address of the repository to clone, and it needs to give it to Git. But the way it's done, we could inject additional arguments to the Git invocation, and we could force Git or trick Git into executing arbitrary commands instead of cloning the repository. So basically, you would go online, I don't know, GitLab, GitHub, you would see this clone with my IDE buttons, and you would click it. If you accept cloning this repository, an arbitrary command would be executed instead, and it would be chosen by the attackers, obviously. So it requires interaction, but it's something that's part of everybody's workflows. I use it personally, or maybe I use it a bit less now, but it's something it's made to be useful. It's made to be part of your workflow. It's made to make your life easier. So everybody's using this kind of features. And it's really hard to defend against it, except if you start reviewing every single link on which you are clicking, which is not easy.
I also wanted to know what sort of tools one would use to discover this type of vulnerability. In other words, are you parsing the 1,000 lines of code statically, or are you running a dynamic tool such as fuzzing?
So first of all, the first thing we do in every audit is we use our own product, which is a static analysis tool to check the code for us. And if it finds something, then we can just use it, verify it, and directly report it. And if it doesn't find anything, which I think never happens, it always finds at least something vague that we can then look more into. Then we have to do it manually. And then, we also use code editors or code viewers for us. We don't edit it. We just read a lot of code. And then, of course, we also set up the application to have a debugging setup to poke at it a little bit dynamically. But regarding tools, it's our own static analysis engine and code editors.
And what's cool with VS Code is that you can, so basically we've been looking at the code of VS Code in VS Code, and we can also debug VS Code with VS Code's debugging features. So it's why it's so practical and everybody loves it, right? It's really well integrated. And even for us, when you do security research in general on such things, getting the right debugging setup and even like being able to build projects could take some time, could be a tedious task. In the case of VS Code, it was really, really useful and easy.
So you get these bugs and you're going through them and you find one that's interesting. I wanted Paul and Thomas to walk me through the timeline of when they realized they had the real thing and what they were doing in the next few days.
So we've been reporting so many vulnerabilities in the past 2 years. We've been in the Sonar research and development team. We have a really established disclosure process. So once we have the bug, we think that maybe something, we confirm it. So we try to, let's say, weaponize it. In practice, we're not making it like distribute malware or anything. We're just making pop a calculator, which shows that we could force the user to execute a simple calculator, which is nothing crazy, but it's a visual, and you see and you know that the command was correctly executed. So once it's confirmed, we went through the MSRC platform. So it's like a bug bounty platform, but it's specific to Microsoft. You would register, you create a new submission, and you put all the details in there. So we have a small advisory of our observations. What's the impact of the vulnerability? How can you exploit it? And how we think it should be remediated. So we share all this information for the 2 bugs. So let's say between the discovery of a bug and the time we create a new submission on this platform, it's likely 2 or 3 days. It's easy for us to create this advisory and share it. And then I think Microsoft tries to this 120-day kind of disclosure policy, but I don't think they apply it for every single bug. But basically, they promise they will get back to you in a short amount of time. And in our case, everything was fixed within, I would say, 2 months, which is, I think, quite efficient, because I think internally it needs to get dispatched from the security team to the developers. And then the developers need to think, okay, in my next sprint, I'm going to fix it. And then they need to fix it. It has to go through reviews. And when you fix a security bug, you don't want to leave the patch out in the open for everyone to see. You want to directly release a new version that everybody can install and update to benefit from this patch. So I've also things I need to kind of align with release dates and everything. So I think the 2 months, let's say, delay is not crazy, like for companies the size of Microsoft. And for us, it's perfect because we use this 90-day disclosure policy delay. I think it's pretty standard in the industry. Google Project Zero has been using it for a long time now. And basically we say, okay, we report everything, and starting from this day, we give you 90 days to fix it. And if you patch everything before, it's all good, everybody's happy. And over 90 days, we will come back to you and say, okay, maybe, like, did you start working on it? Can we help? Can we maybe give you a patch? Can we make things faster? And if after this 90 days, nothing was fixed, we may release a public advisory for people to be able to defend against these bugs. Because if they are either exploited in the wild or if they are already known by other people in the space, they may get exploited. And we want to give ways to VS Code users to protect themselves. But in the end, Microsoft was always on time, and they always fixed everything pretty quickly.
No, I would say that's pretty much it. I mean, this was specific to Microsoft, but it's pretty similar with all the other vendors. Some of them are really responsive, and I think the record was that things were fixed and deployed hours after our report, which is very cool to see. Sometimes they do take more time. Sometimes we have to annoy them a little bit more via email to, hey, do you have any patches? Please fix this. But in the end, almost every vendor fixes the vulnerabilities we report. So yeah, it's a nice impact to see that the whole ecosystem is getting more secure by this.
So in the end, did they get 1 or 2 CVEs?
So we got 2 CVEs. So we're really like the bug class, like the reason why this bug exists is different for the 2 cases. So even if they are kind of close in the code and kind of in the same components, they got 2 distinct CVEs. The first bug that was using the Git local configuration got a CVSS of 7.8, and the second one, based on protocol handlers, got a CVSS of 8.8. And I think something that we still need to mention in these cases, these bugs require interaction from the user. You need to clone or to import a malicious zip file that somebody just sent you or hosted somewhere. In the case of a link, you need to click the link and do a few actions. So it requires interaction. It's not like, 0-click RC something. But I think in the context of code editor, it's fine. It's action you're going to do in your day-to-day workflow anyway. So we can say it's still a risk. And also the attack vector, in the CVSS, you can be local, you can be remote, you can be a network. And it's called remote code execution, but I think a better term for it would be arbitrary code execution. It's remote, but because the attacker is remote, not because from the remote position they can directly attack you, right? Because of the interaction requirement. So CVSS for such vulnerabilities is a bit tricky to get right. I think it's one of the pitfalls of CVSS system, but it still, tells you may want to update your VS Code instance.
So you're a researcher, and you found 2 vulnerabilities in Visual Studio Code, which is used by roughly 80% of the developer market today. So would that be a dangerous scenario for anyone not patching this?
Because of actions that would be part of your workflow. I would maybe clone some dependency to review this dependency in my code editor, because all developers are using code editors. We as security researchers, we are also using code editors to read code because it's what they're here for. So every time you want to read code and you don't trust it, it's tricky, right? Because you're opening unsafe code, and if you trust a folder a bit too much, and like when VS Code now tells you, do you trust this folder? If you say yes, you're gonna get compromised. So that's why you get tricky.
And it's not only IDEs, right? Thomas also found a similar vulnerability in command line shells and shell integrations, where if you have your command line prompt to basically show you the current Git branch or if files have been modified or not, this will run the same Git commands under the hood. So instead of opening a potentially malicious folder with your IDE, where you might think, okay, maybe my IDE does something not so good here, you might want to only go into the folder in your command line, and even that could get you compromised. Whereas I think most people would think, oh, if I only enter the directory with my shell and maybe use the cat command line utility to look at the contents of a file, nothing can go wrong. But even there, something could bite you. It showed us again that in the world of developer tools, there's no clear boundary of responsibility between the user and the tools. And for every tool, it's kind of different. So as a developer or anybody who uses developer tools, you really have to be careful if you use third-party projects, zip files.
Yeah, so there's the classic trade-off between convenience and security.
Yeah, so we also reported this kind of behavior to the Git maintainers. We said, oh yeah, at no point Git should execute things on my behalf just because I got a Git repository from the internet and I got into the wrong folder with my tools. Maybe it should be disabled by default. Maybe we should only it should only pass the system-wide configuration and the user-wide configuration, and by default never run or never take anything from the local configuration unless I explicitly trust it. Kind of the VS Code Workspace trust feature, but for Git directly. But they said, no, if you trust somebody or something enough to get the code from a remote location, we believe that it's on you. You have to be aware of this pitfall of Git. And it's where we kind of disagree, because every time we present this weird behavior of Git to people, to developers, to security experts, we all get surprised. Everybody gets surprised of this behavior. You never expect that by default some tool would maybe help somebody to compromise your system. For the developers of Git, they know it's part of the threat model, but it's not part of the expected threat model that everybody has in mind when they use Git. And that's why this slight distinction is really important for security. If nobody's aligned on what should be safe and what should not be safe, everybody will get surprises, and it's not the kind of surprises I want to get.
So what's the general takeaway from all of this?
I think a good takeaway of this research is that basically if you don't trust a Git repository, you should not use Git. And Git is everywhere. It's in your code editor. It's in your shell prompt. It's in every single developer tool. And the thing is, it's inherently unsafe to use a Git repository that you don't trust. So it's something to be aware of. And while VS Code shows you this prompt before running any Git action to ask you if you trust a folder or not, for many of the tools, it's not the case. They don't have the same trust-based system. They just run commands directly. Like Paul was saying in this shell prompts, that means if I have a fancy terminal as a developer, I like to have fancy stuff. And even as a security researcher, I like to have fancy stuff on my laptop. I just get into the wrong folder that I got from GitHub or anywhere, and I get compromised. It shouldn't be that easy. And I think this is why we have this weird trade-off between I want a deep integration with everything, but I want to be safe. It's kind of exclusive. You cannot get the best of both worlds. You need to remove some fancy features of your favorite tools if you want to be safe. And if you know that all the code you're reading comes from your colleague and you trust them, you trust everybody, you get maybe nicer tools and visualizations, but it's really at the depend of your security. For me, I really like to see all these trust-based systems, but you have to use it right. And I think in general, editors publishing these tools that kind of embed this trust-based features should tell you if you click yes, it's on you and you will get compromised. Because I still think that when you get this kind of screen, you will likely want to say yes, because this weird screen is bugging you and you don't want to take the time to read everything and you just want to say yes. And I did it and I have done it all the time and now I stopped because I know it's really unsafe to do it now. And I think In general, everybody should be more upfront about this stuff. Say, if you click yes, something bad will happen, and it's on you.
I'd like to thank Paul and Thomas for coming on the show and talking about their research into the code editor and the 2 vulnerabilities that they found in Visual Studio Code extension. There's always the convenience of swatting away dialog boxes and warnings, but we have to remember that there's probably something behind that. Be careful when globally accepting something. There may be cases where you don't want to extend that trust. Hey, if you enjoy this podcast, tell a friend. I bet there are others who like commercial-free narrative InfoSec podcasts. I have so many stories about hackers who are making a positive difference in the world. And be sure to check out Error Code, my new podcast that focuses on IoT and embedded security. Error Code is available now wherever you get your podcasts. Let's keep this conversation going. DM me at robertvamosi@infosec.exchange on Mastodon and tell me what you like and even what you don't. Hey, I have some great conversations coming up with the rise of bots, the threat from China and Vietnam, and some files coming out of Russia that are the equivalent of the Snowden files here in the United States. Subscribe today. I don't want you to miss out on these. The Hacker Mind is brought to you every 2 weeks, commercial-free by For All Secure, the makers of Mayhem, an application security testing solution you can try for free at mayhem.security. For the Hacker Mind, I'm Robert Vamosi.